So let's consider this problem. So a motorboat going downstream overcame a raft at a point A. So just for context, a motorboat basically has an engine of its own. So on still water, it will have some velocity of its own. It will have some speed. Um, so it's going downstream. So it's so downstream. It basically means that the direction of the motorboat is the same as the direction of the flow of the stream or the river, basically in this situation, and it overcomes a raft. So I mean, a raft does not have any engine or any any speed of its own. So on still water, it would be the speed will be zero, just for context, and so it overcame a raft at a point A. Fine, okay. Now 60 minutes later, right? So I think it's better to start drawing stuff. That helps. So let's consider this direction as downstream. Okay, so let's say this is the river, just considering it as a line because it's basically a one-dimensional problem, as you will see. So there is this point A, right? This point is of significance. So a motorboat is basically going downstream. Okay, so we have just drawn the stream velocity is in this downstream direction, and this point A where motorboat basically overcomes a raft. Okay, so 60 minutes later it turned back. So by it they basically refer to the motorboat, and after some time passed the raft. Okay, so it turns back after an hour or 60 minutes, and after some time, so it takes some time to again, like, it at a direction it changes, at a point it changes the direction, and after some time it basically passed the raft again. So remember, raft basically is the speed of the raft in any stream, in any river, is same as the speed of the river or the stream, because it does not have any speed of its own. So basically, since, like, the river is flowing downstream, the raft is also flowing downstream with the same speed. So at a distance L equal to 6.0 kilometers from the point A. Fine. So let's consider that to be point B. Sorry. So let's consider that point to be point B, where they again meet. So A and B are the meeting points. So A is the initial meeting point and B is the second meeting point of the motorboat and the raft. So find the flow velocity assuming the duty of the engine to be constant. Okay, fine. So we have read the whole question now. We have highlighted some of the important stuff. We have drawn, I mean, we have also have to incorporate uh, these two uh, these two variables into this, but let's see. So they are asking the flow velocity. Flow velocity is nothing but, so obviously the direction is downstream, so basically they are asking the speed of the stream or speed of the river, basically, assuming the duty of the engine to be constant. So duty of the engine is constant, which means that uh, basically they're trying to say that, on if, like, by engine, so this engine is basically of the motorboat. So the motorboat has basically a constant velocity on still water, because we'll come to that in a minute, why I am specifying still water. So okay, so basically at t equal to 0, let's say I'm using the notation t. Fine. So t equal to 0, uh, basically they meet, let's say. Okay, and the motorboat goes till point C and it turns back. So this is like after an hour, so I'm writing it in hour directly. T equal to 1, so t, everything is in hour now. Okay, and then after a while, so after some time, as you can see over here, so after some time, so let's say that time is x. After some x hours, it there is a second meeting point. So b, it is basically t equal to 1 plus some x. Fine. Okay, so we have defined the times also, right? Okay, very good. So now let's also define the speeds. So let's say river speed, I'm just calling it a river, can be anything actually, stream, river. So river speed, let's say we call it v r. So r goes for raft, as r goes for river, is the same. Okay, so raft speed, because as I told, raft does not have any engine of its own, so it's the same speed. um, if we consider the motorboat, let's say the motor, I'll just write mot, speed on still water. So there is a reason for still water, is basically, let's say it is vm. So why am I considering this still water thing? This is important because this constant duty of the engine basically means that on its own it has a constant velocity. Now if the motorboat is going downstream, that is, if the direction of the motorboat and the direction of the river flow are the same, then obviously its final velocity, I mean it's absolute, I mean the speed would be more. So it will basically become vm plus vr. And when it is flowing upstream, that is opposite to the direction of the stream, its velocity will be vm minus vr, and obviously vm is greater than vr, otherwise motorboat cannot come upstream. So basically, if we consider we'll consider first of all, sorry for the oblique line. So if we consider the motorboat from A to C, the it's basically the, I mean the velocity, the speed is, it's from A to C, so it's in the downstream direction. So it is Vm plus Vr. And if we consider from C to B, when it comes back, the speed is Vm minus Vr. Okay, so this is the motorboat, and of course for raft, it is basically just Vr. Okay, fine. So we have the speeds. Very good. So okay, let's consider simply the raft, which is very easy. Sorry. So from the raft goes from A to B in the time, motorboat goes from A to C and then back to B. Okay, so for the raft, it has a constant speed of Vr in the same direction, that is from A to B. The raft goes from like raft covers the distance AB. The time taken is basically 1 plus x. So speed equals distance equals speed into time. So basically the distance from A to B is L, and we'll just consider variable now. So L, like that is the distance between A and B. So L is equal to VR, which you need to find, that is the flow velocity. I mean the magnitude of the flow velocity is what we need to find. VR into the time taken, so that is 1 plus x. Fine. This is the raft thing is done. Now if we consider the motorboat, So motorboat first has traveled AC with this speed, CV with this speed. So now if you see AC is equal to AB plus BC, right? Okay. So what does this mean? So AC is basically in 1 hour. So again, speed into time. So speed is Vm plus Vr into time is 1, right? Is equal to AB. AB is very clearly L, right? Plus BC. So basically I have wrote it as BC. It's basically like it's coming from C to B. So that is Vm minus Vr, right, into what is the time from C to B. So it's 1 plus x minus 1 basically. That's the, so x, right? So see, if we take these two equations, okay, let's see now. Let's take these two equations and proceed. So I'm just solving these two. This is 1, this is 2. Oops, this is 2. So 1 basically gives me L is equal to VR plus VR into X, right? 2 gives me right, 2 gives me Vm plus VR, nothing, I'm just opening the brackets, that's it. L plus Vm x minus VR x. So if you observe, if I just add these two, right, if I just add the LHS and the RHS, it's L plus Vm plus VR is equal to, so these two cancel out, becomes L plus Vm x VR. L and L cancel out, VR and VR cancel out. So interestingly, and of course Vm can't be 0, so Vm equal to Vmx, x is equal to basically 1. So it basically means that, yeah, so basically like the time, so you understand, right? So basically x is also equal to 1. So b at B the time is basically 2 hours, right? So now if we, so we have to find out VR. So it's easy. We'll again take equation 1 and put x equal to 1 there. So that means L is equal to VR plus VR, which is equal to 2 VR, right? So I think I should have taken tau. So basically in the question tau is 1. That is why like VR is coming out to be L by 2. Actually it would be L by 2 tau, which is actually the which is actually given in the answers and solutions part of Irodov. So it's basically L by 2 tau, but over here tau is 1. So if you put like L equal to basically 6 kilometers, so your VR comes out to be 6 by 2, which is 3 kilometer per hour. Yeah. So basically this is how first question is solved. So yeah, thank you.